It's a pleasure to introduce Maria Pina Limongelli. Maria Pina, could you introduce also yourself?
Thank you, Carmen. I'm Maria Pina Limongelli. I'm an associate professor at Politecnico di Milano in Italy. And thank you, Carmen, for the invitation. And this workshop for me has already started to be very interesting because I realized that I share most of the concerns that Steinar just presented. And you will see that also my talk will start more or less from the same question. The specific focus of my contribution will be about the difference or maybe the importance of global and local durability indicators. But I think we, first of all, need somehow to agree on the meaning of durability indicators. So first of all, what is durability? If we look at everyday language, and this definition is from the dictionary, durability is defined as the ability to last over time, resisting wear, deterioration, and breakage. Now, this, of course, is not an engineering definition. So what I tried to do is to go from this everyday language definition to an engineering definition. And this is why you see some of the words that have different colors. So to last in our language as engineer, to last over time means to provide functionality over the life cycle. This is what we mean by durability. And resisting means without excessive maintenance to limit deterioration. We use the general term deterioration, which includes degradation, which is a slow process, or damage, which is a fast, quick process, such as a breakage in everyday language. So our engineering definition of durability is the ability to provide a functionality over the life cycle without excessive maintenance to limit deterioration. So let's go to the first question that Steinar was asking. Is it performance or durability? Durability indicator is a performance indicator. I don't have the answer, of course. This is something that is very interesting to discuss. I have an interpretation. So to me, durability is not by itself a performance. And this is represented in this picture. So we have a performance, which might be any performance, could be reliability, for example. And this reliability in time decreases due to deterioration, as I just said. So we might have let's say average durability. What we expect will be the durability of the structure. And for durability, I mean the reduction, the time, the period of time needed for the performance to decrease up to a, let's say, minimum level, which we can call target performance. And then the structure can be more durable than expected or less durable than expected, which means that deterioration progresses faster than expected or more quick than we expect. But durability itself is not maybe the performance. The performance is what decreases, and the durability is the capacity, the capability of the structure to have this decrease in an interval of time long enough. But anyway, what is clear from the definition of durability is that it is, of course, strictly related to deterioration. And now I go to, let's say, the main focus of my presentation. So let's try to go toward the difference between global and local indicators of durability. But before this, we have to get an understanding on what an indicator is. So to me, an indicator is a characteristic of a system that conveys information about the state of the system with respect to a specific aspect. And when I say specific aspect, I mean a specific function, a specific functionality. So this is, again, my perspective that durability is not the functionality by itself. So durability or deterioration, because we understood is they are of course strictly related, are characteristic of a structure that convey information about its deterioration state that can affect durability. This is a durability indicator, I think. So now there are local and global durability indicators. And I think today already Alfred and Steiner already mentioned some of the local durability indicators, but there are also global durability indicators. And are they related? This is the first question. And the answer, of course, is yes, but how are they related? So let's see from the conceptual point of view how they are related. We understood, we said that durability and deterioration are, two words that describe two faces of the same coin, let's say. So degradation, deterioration can be corrosion, can be fatigue. We have several different types of deterioration. And here I list some of them. All these deterioration that I write here they all start and they can be interpreted as local deterioration. But this local deterioration, of course, can affect the global state of the structure, or corrosion can occur in several different locations of a structure, on several different components. So it can become a global deterioration. But in any case, even a local deterioration that stays local can affect the global state of the structure. And from the global point of view, a corrosion or fatigue or any other of these local deterioration phenomena can cause, let's say, can affect reinforcement, so can affect strength, can affect the global performance of the structure. So, as I said, there are local and global indicators are different, let's say, ways to convey information about deterioration. And we can describe this deterioration using local indicators that describe this local phenomena, or global indicators that describe phenomena at a larger scale. So the question is, shall we use local indicators? Shall we use global indicators? We understand that they are, of course, connected, but how to choose which indicator is best for each phenomenon, for each deterioration type? I think one way to see this is to look at the scale of deterioration, at the size of deterioration. Let's consider this size. So let's assume that we have an indicator that describes this phenomenon, this corrosion, this spalling, at the scale of this portion of the structure. Of course, at this scale, this phenomenon is very important. So an indicator that conveys information about this portion of the structure will be very much affected by this deterioration. But if the scale changes and we have an indicator that describes the performance of a, let's say, larger portion of the structure, this indicator will be less affected by the same deterioration, and we can proceed. If we have an indicator that describes the performance of this entire joint, it will be less affected by this deterioration, and we can proceed. And if we go at the bridge scale, for example, an indicator that describes the deterioration at this scale will not, an indicator, that describes the performance of the entire bridge will not be so much affected by a deterioration that occurs there. So which indicator to use, global or local, really depends on how much this indicator is affected by the phenomenon that occurs. So how much this indicator is global or local. And global, I used this term, global and local, but I didn't define them. So a global indicator is an indicator that provides information about the entire structure. For example, modal parameters are indicators that reflect the performance of an entire structure. And these indicators can be very much affected by phenomena that are global, like settlement, like scour, like seismic damage. Local indicators provide information about specific locations or portion of the structure. So they are very much affected by other types of local phenomena like corrosion, fatigue, all the phenomena that I mentioned before. This doesn't mean that corrosion does not affect a global indicator, never. It just means that a global indicator is very poorly affected by corrosion at a specific location. So if I use a global indicator to, let's say, convey information about corrosion, is not a very effective indicator. Now, this is something on which we, let's say, started a discussion in our bulletin, the bulletin of TG 3.3 that Alfred was mentioning. We have a chapter of the bulletin that deals about local tests, and another chapter that is about global tests. Local tests are tests that allows to measure local indicators. Global tests, like, for example, dynamic tests or proof loading, are tests that allows to measure global indicators. And so for local damage phenomena, let's say, non-destructive tests and local tests are much more effective to provide information about local phenomena and local indicators, of course. Whereas tests like a dynamic monitoring on a whole structure, on a whole bridge, or even a static test can provide more effectively information about global deterioration. This, again, doesn't mean that a global indicator is not affected at all by a local damage phenomena, but it is scarcely effective. So the uncertainty on a global indicator about a local damage phenomenon is very high. This is the difference mainly. So what are the global tests I'm referring to? Could be static tests like proof loading, during which we measure, for example, displacements induced by loads by trucks placed on the bridge. And we measure displacement that provide information about the stiffness of the structure. Or can be other type of static monitoring. For example, here is an example of some tests that we have been carrying in, well, they are not tests, it's a monitoring that we have, a monitoring system that we have installed in some bridges in Milan in the framework of a research project. This is a satellite monitoring, and similarly to this, we measure displacement. In this case, the indicator is the indicator itself is not displacement. The measurement is displacement that provides information about stiffness. This is the indicator. If the stiffness decreases, there is a deterioration. This is the idea. So would be the deterioration indicators. And we have also, of course, dynamic tests. Dynamic tests could be performed installing accelerometers on a structure, measuring the response to vibration, and then extracting global parameters such as those I was mentioning before, modal frequencies and modal shapes. The same can be done also using non-destructive tests. In this case, I put this picture here just to say, I'm not saying that non-destructive tests are only for to identify local indicators. There are, of course, non-destructive tests that identify global indicators, but most of the non-destructive tests identify local indicators. This is an example of global indicators, modal parameters extracted from acceleration recorded on a bridge. And in this case, the deterioration indicators that we use are modal frequencies. You see here the modal frequencies of 7 modes of this bridge for several different, for the 3 spans of the bridge. And changes in these parameters provide an indication of a deterioration, which could be, for example, this is a process. We have the bridge, we measure signals, we make some pre-processing to clean the, to reduce the uncertainty, let's say, from the signal. We remove the effect of environmental sources like temperature. For example, here you see the modal frequencies that change with temperature. And when we remove the effect of temperature, there are methods that allow to identify possible changes in these frequencies that identify a damage. And we can do it through frequencies or through modal shapes. But now the question is, okay, with the frequencies or modal shapes, I identify a variation. How is this related with durability? Because at the end, this is what we are talking about. We're talking about durability. We don't use these indicators, as I'm calling them, directly to go from deterioration to durability. What we do usually is to use these parameters to calibrate a model. And we use the model and let's say, not just a finite element model, but also a deterioration model that provides information on how deterioration evolves in time. And using this model, we estimate the future service life. So here is where durability comes in. We have a model that allows us to modify the, let's say, the indication we have without monitoring information. Let's say that without monitoring information, using only, for example, design parameters, we can say that this is the way deterioration will evolve in time. So we have this expected life. When we update our model using the measurement, we can come up with a longer service life or even with a shorter service life. The important thing is that we come up with a more accurate estimate of the durability of the structure. So this is how we use these global indicators to achieve information about the durability. So just some points in my presentation. Durability, what are durability indicators? Are indicators that convey information about the capacity of a structure to provide functionality. So functionality and durability is not the same for me. Functionality without excessive deterioration. Local and global indicators are different in the sense that they have different sensitivity depending on the deterioration phenomena. Global indicators are more suited for phenomena that affect the performance of the structure as a whole, whereas local indicators must be used to identify deterioration at a local level. And global indicators of deterioration are not used by themselves as they are to assess durability, but we use them through a model of the structural performance and the evolution of the structural performance in time. And this concludes my presentation. Thank you.
Thank you, Maria Pina, for the clear presentation. I think that illustrates very well your views that are very interesting. We have a question from Can You Pen that I don't know if for you, but I am sure that you can respond. And is what is the difference between the durability indicator in the design stage and in the construction stage? The construction phase must consider the test efficiency of time. I think that is on time, but is there, you have in the Q&A.
Well, I think it's a question of uncertainty. I'm not sure I understood the question as it was posed. The durability in the indicator in the design stage is a forecast of a future situation that accounts for what I plan to do. then during the construction phase, durability becomes depends on how the construction phase differs from the design phase. So am I doing exactly as I planned in the design phase? Of course, there can be an update in the construction phase. I don't know what does it mean, the test efficiency of time. This I don't understand. Maybe the person who asked can be more can explain a little bit more, because I don't get this part. And I hope that this was, I mean, I answered this question. This is what I understood.
Thank you, Maria Pina.